vectors last week, we defined and described what a vector is. Not Kamal, Khalil, what's a vector? If you have physics, it has two things. Dante, what is it?
Something that shows direction and distance, and how long.
Okay, so it's something that shows direction and distance. So magnitude and direction. So graphically, when you're representing these, you need to put an arrow on the end of the stick. The arrow indicates direction. Like, that is exactly the same length, supposed to be anyway, but the opposite direction. So they're not exactly the same vector. This is vector A. This is negative vector A. And the length of the arrow indicates the strength of the force. 50 miles an hour, 2 miles an hour, whatever. However long it is meant to indicate that magnitude. Today we're going to do, hopefully, a simple thing, which is to calculate dot product with vectors. Physics people, have you done that already? Any idea? There's at least one or two of you in physics. So, well, we'll do dot product and work with some components. Today's homework is Delta Math, and it's due Thursday. Tomorrow's going to be an insane day of pep rally stuff and schedule disruptions. No? You guys don't know what this, but it's an insane day. So, exit card, Thursday. Okay. So these are the three things you should be able to do from last week. Can you, given those two coordinates, find vector CD in standard form, and I will ask someone what that means. Find the magnitude of CD, and remember, sometimes the textbook puts double bars on it, sometimes it's single bars, and how to find the direction of CD, which is finding an angle from that being zero position. Yes?
Component form is the same as standard.
Component form is the same as standard form. So standard form, standard position, component form, they're all the same thing. Yes?
Is it n minus start or start minus n? Because I kind of forgot.
Okay, so guys, please write these down, write the coordinates down, so that when we go over things, you at least have a place to put in the work. Component form, standard position, okay? So as a vector, if we started at coordinate C and ended at coordinate D, that's indicating a direction and a magnitude. Like, if I walked this far, that's my vector. Putting it into standard form, also called component form, also called standard position, that means if you were to pick this up and make the beginning start at the origin, where would the new ending be? So I need to move my starting point back 3, up 8. So if I need to move the start that way, I need to move the end back 3 and up 8. And mathematically, Andreas, you were saying how to do that?
Add minus start.
Okay, so vector CD,
So it'd be 5 minus 3.
5 minus 3. So the end x value minus the y, end x value minus the start x value. 5 minus 3 is 2.
And then, negative 11 minus negative
Negative 11 minus negative 8
So-
equals negative 11 plus 8, which is
8. Negative
down 3. Okay? Sebastian? Holly? Pilar? Khalil? N minus start. And so it's subtract the x values, subtract the y values carefully, being careful of the negative signs. So there's my vector. Hayden, how do I find the length of that stick? Okay, let's look at, so here's the vector. It went down, over 2 and down 3. Pythagorean theorem. But the big deal is, if I was looking at the coordinates, I would have to do distance formula, which by the way, Pythagorean theorem is just distance formula. But once it's in component form, the change in x is 2 units. It is this number. Four squared plus negative 3 squared, 4 plus 9, 13, and it's under the square root. That's the length, the magnitude. Okay, do you remember how to find the direction?
Yeah, tan inverse,
Tan inverse of what?
3 over 2.
Negative 3 over 2. The y over the x. Chloe, did you get an answer? You don't have a calculator out. Lexi, do you?
I got 3 over 4, that's a 3 under 4, because it's a negative 56.
Okay. Do you agree? Did you check it on the?
Yeah.
Okay, so tan inverse negative 56, or 304. I didn't specify how to give the answer, so you would both be right. But you gotta look. Did I really wanna go there? Did I really want the negative 56? It is, yes, that is the direction I want. However, Dante, what would I have to do if it was vector negative 2, positive 3? Tan inverse is gonna give me the same answer. It's not gonna be positive 56. One 180 minus 56. This reference angle is the 56, so 180 minus 56, so 124, something like that. Something like that, yeah?
Just depends on the longest.
So, yeah, all right. Here's the catch. Now when you do this tan inverse to give you the angle, you need to look at it. Yeah, if it's down here and the angle the calculator tells you is negative 40, we're good. But if you actually were up here and the calculator tells you negative 40, you need to draw it and be like, oh, no, 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 no. No, I want that guy. I want the bigger one over there. Got it? Okay. So we're down here and I say tan inverse. And it tells me 37. How are you gonna get the correct answer to get there? 180 plus 37. Because that top part up there is 180 plus that reference angle of 37. Okay? So that's the tricky bit here. Okay. Alright, so that was a recap on stuff. Now I need you guys to understand dot product, and be able to do dot product. And can you just write this down? If U is, you might want to pick different letters, because some of you write the letter U and the letter V exactly the same.
Can I just use X?
Sorry?
Can I just use X and Y?
Not a great idea using X and Y just, but if you want to,
Let's choose A. What's the first one? Use those.
Okay.
alright. So dot product, we're multiplying the exponents, or x components of the vectors, not coordinates, but vectors together, and we multiply the y components of the vectors together, and then we add them. And what this does is it tells us how much the vectors are working together or against each other. For any of you like run or bike or boat something with speed, where you have feel the wind, like I've done bike touring. Don't do bike touring in like island spaces, because there's always wind and it's always going against you. When you gotta go 60 miles a day and 15-mile-an-hour wind is pushing you backwards, and you're biking 20 miles an hour, but you're still kind of not going far. Okay. Just to show you, vector t here is 1, 2, 1. This one's vector t, and vector u is -3, 7. Okay, does it look like those vectors are going in the same direction, opposite direction, sort of the same direction? Like, they're both going up, but they're going differently left and right. So, I'm thinking the dot product's gonna be positive, but not huge. So let's calculate, dot product is going to be x value times x value plus y value times y value. So that's the dot product. And it's called dot product because it's a dot and it looks just like multiply. I'm sorry, it's not exactly multiply. We can't really multiply by vectors. So there, it came out to be a +1. So they're both going north, but one's going east, one's going west. They're not exactly going the same direction. Yeah.
What is the one
Okay. In physics, it means a lot, and we're going to use it to find the angle between vectors. But it doesn't. Right now, if it's positive, the vectors are sort of going in the same direction. If it's negative, they're sort of going in the opposite direction. What do you think if it's 0?
The negative magnitude are the same, but they're going in opposite directions.
If they go in opposite directions, it should be a super negative.
It's
Kelly?
like, well, I don't know what he said, but it's like the same magnitude but different directions, like, is that what he said?
Sorta. So, okay, we'll see. Can you guys do the next two? Find t dot v and u dot v. So what did you get for, Jack, what'd you get for the second one?
I have 34.
So, that's the two vectors. They're almost on top of each other, so it's a really large positive number. The other one was negative 3, 7. So it was a small positive number. They're not exactly going the same place. Sam, what do you get for U dot V, these guys?
0, 0.
Negative 42 plus 42, that's 0. All right, well, let's look. Negative 3, 7, and what was the other one? 14, 6. They make a right angle. So that's, when the dot product is 0, if this is frictionless ice and I'm skating sideways, gravity is going straight down and I'm moving sideways. Is gravity helping me move sideways at all? Is it stopping me? No, because we're saying it's frictionless. Am I helping gravity in any way? No. So is it helping me? No. Is it hurting me? No. Am I helping it? No. We're just going our own ways. Literally opposite, not exactly opposite, but going our own way. So if the dot product is 0, right angle. Did they have to be the same magnitude? Did they have to be the same length? Nope. Could they be? Sure. Do they have to be? No.
So that's it's more than 0, it's going to be acute angle less than 0.
So if it's, yes. She just said if the dot product is something positive, bigger than 0, it's going to be an acute angle. If it's negative, it's going to be an obtuse angle. Yes. And if it's exactly 0, it's going to be a 90-degree angle. Perfect. Yes. Yes. Okay. We can get things that are parallel, they go in the same direction. They use the word anti-parallel. I don't really know what that means, but they're trying to tell us it means opposite direction. And have you guys heard the word orthogonal before? Okay, I apologize. They have so many words for perpendicular. Can you guys write this one down? Orthogonal means so it's perpendicular, or it makes a right angle. You get 90 degrees. If any of you speak Greek, it means perpendicular in Greek. You go to the orthodontist because you want your teeth to be like straight up and down. People are still right, so I will. Is that good? Okay, so like I just said, orthogonal means the dot product's going to be 0. And before we try the examples here, how are you going to figure out if they're parallel? dot product isn't gonna tell us. What?
Just graph
Graph them? Well, the first two examples we did, I showed on the thing, they were really close, it was hard to tell. Is there a way to, how would we tell slope? Do what?
Y equals that.
Y what?
Y equals that.
Well, but I don't have a line, I have a slant. What is slope? What's the equation for slope from geometry? Not y equals mx plus b, that's
Y,
the.
Y to, it's like the average of Y and then the average of X.
So it's the change of y over the change in x.
Yeah.
Okay, how did we get these vectors? We did the change in x, we did the change in y. So you know what? Slope is the y over the x, the y over the x, the y over the x. So you would find out if they're parallel, or any of these parallel.
Yeah,
Yes.
Yes.
Oh,
Wait.
okay, Zach, what did you see? You were like, no, wait, yes. T and U are parallel. U and V, T and U, which ones? T and U, why? This reduces, so be careful. Some of you, on a quiz a while ago, said, no, they're not equal because 8/4 is different than 2/1. Well, but it reduces to 2. So, for each of those, are T and U perpendicular, parallel, or neither? Find out for each of those 3 pairs. And then compare with the person next to you. Khalil, do you want to put the problem up for us? Sebastian will put the second one up. It's not a challenge, it's just you're not doing it. Okay, so some of you have not checked in yet today and are like confused as to what we're doing. So can someone who knows what's going on tell us how to figure out if the 2 vectors are, hello? So T's slope is 4/2, which is 2. And I put a little m, subscript m, to mean slope. So he said y divided by x, that guy's y divided by x. 4/2 is 2, 2/1 is 2, they have the same slope, so they're parallel. And before we had like numbers, Sasha was like, hey, why don't we just graph them? That would work as well, but without a grid, you're not sure that you're totally accurate. Okay. So Jack, then how do I do number 2?
Well, T T is two of the one.
So T is, the slope of T is still 2. What's the slope of V?
Negative.
-1/2. Are they parallel?
No.
Because those slopes are not equal. Okay.
So they're
Just because they're not parallel, do they have to be perpendicular?
I guess.
So how can I prove that they are perpendicular, or also known as orthogonal, by maybe reading the words up here? What do I check? Jack, what do the
Oh.
words say?
Only if it's
Only if its dot product is 0. So what's the dot product with T and V? X times X,
yeah.
which is,
4.
again, plus Y times Y.
So it's
Do you guys know the 3 dots? What do the 3 dots mean?
2, 4.
Therefore. What's the upside down T?
Perpendicular.
Perpendicular. Okay, because the dot product was 0, those 2 vectors are perpendicular. Okay, Sebastian, your turn. T and W. Here's T, here's W. Check the dot product. How do I do dot product? So, for the 4th time in 5 minutes, x times x, y times y. So, what is it? What is the x value of the t vector, and what is the x value of the w vector? So 2 times -3 plus, and now I need to multiply the y values. Okay, so what does that become? Okay, are they orthogonal, which means perpendicular? No. Brianna's gonna tell you, the answer is no, because the dot product is not 0. Are they parallel? But I can't tell that from the dot product. Brianna, what are you checking to be sure that they're not? They're slopes. So again, the slope of T is still 2, and the slope of W is 5/3. They're not parallel either, so they're just slanty. They intersect at some non-special angle. Okay, yeah.
Can't you tell if it's perpendicular if like the slopes are the opposite?
Negative reciprocals, yes.
Yeah.
We want you to use dot product in this. But yeah. Okay. Just here's some properties. The dot products, if you trade them around, are gonna be the same. Yeah, can you guys write these down? Just because. like, if U is, hey, this vector's going 3 units to the right, 4 units up every second. This is 5 seconds, how far did it go?
Yeah.
So it's just a single number, how many vectors went this direction?
Okay.
5 of them, 1.5 of them, -3 of them. All right, just to see if you can do these things, given these, ooh, and no matter how they're written, do you remember what the I's and J's mean? Laura, do you remember? If you had to guess, does I match up with X or does I match up with Y? That's alphabetical order. So I agree with you, I hate this format, but those of you headed towards any kind of physics, mechanics, engineering, something, get used to it. But for here, if you want to, you can rewrite that I and J, which is the first thing that I do. I rewrite them as vectors the way I like to see them, and then do the math. Okay, can you go through and figure out, by doing the dot product, the angle obtuse, acute, or right? And someone not Sasha, can you tell me how we check that? Clara, do you remember? If the vectors are acute, what's the dot product? The dot product would be positive. Khalil, what's the dot product if they are obtuse?
Negative.
And Alexia, when they're right angles? Okay, so can you do those? get for the first one? Dot product wise. What'd you get? Hey, guys, you should be able to get this by now. The dot product for number one, 5 times 12 plus 3 times 4. 5 times 12 is 60, 3 times 4 is 12, so it's 72. So is it acute or obtuse? Wait, what is it? Acute, it's gonna be a small angle. Kelly, what did you get for the, number 2? Okay, so this one, negative 40 plus 26, so she saw that it was gonna be a negative number, didn't care that it was negative 14, because I didn't ask for the actual number. So that's an efficient way to do it. She saw that the bigger thing was gonna be negative, so just like that, it's negative. Marcy, how about number 3?
I didn't do those things. Is it also obtuse?
Is it also obtuse? Well, let's look. So 4 times negative 3 is negative 12, and then 5 times negative 7 is negative 35. It's definitely a negative number, so yeah, it would be obtuse. Leo, how about number 4?
I got disease.
We got that it would be acute. I get positive 10, but negative 56. So it's a negative dot product, so it's gonna be obtuse. It's gonna be bigger than,
Oh wait, I think it's leave
oh, did you do this one?
Yeah.
That one? Yes.
Yeah.
Okay, that one's 30, and that one is, gonna be acute. And the last one is obtuse. Yeah. How is number 5?
Yeah. No, 7.
7. Okay. Okay, 7. What's the component for the y's? It's not, there's nothing written. So how many, it's 7i plus 0j's. Okay? That's what makes this form challenging, is when it's got the i's and the j's and one of them is a 0. But 7 times negative 2 and 0 plus times 5. Marcy, question? One more formula to write down. Sorry, can you write this down? No, we're not writing it. Those are magnitudes. So that is, what is the strength of vector V and what's the strength of vector U? All right, so, again, bell did not ring. Keep T dot W, vector T and vector W, what is the dot product gonna be? Or tell me the numbers I should be doing. -6 plus -20. So is my angle gonna be less than 90, more than 90, or exactly 90? More than 90. Okay. Cleo, I need the magnitude of T. Why did I do W? Sorry, magnitude of T. How do I find the magnitude?
Pythagorean theorem.
Okay,
2 squared plus 4 squared.
under the square root, so 4 plus 16, square root of 20. What's the magnitude of W, Leo? Magnitude of W, how do I calculate it?
You do the Pythagorean theorem, so.
Okay, guys, again, the bell didn't quite ring yet. So what you need to do to find the angle, cosine inverse of that dot product. Over those guys. I don't remember if this is on tonight's Delta Math or not. Delta Math is not due till Thursday, so if it is, we'll have some time tomorrow to practice. But yeah. Great. Vector basics, there we go.